Metrics are numerical values that reflect the performance, availability, and overall health of Azure services and resources. They enable administrators to observe trends, set thresholds, and respond proactively to unexpected changes. By tracking data points, such as CPU utilization or memory usage, metrics help identify usage patterns over time. In Azure, metrics complement logs by offering quantitative insights, while logs provide qualitative details. Together, they form the foundation of an effective monitoring and troubleshooting strategy. Understanding why metrics matter is crucial as they guide resource optimization, reduce downtime, and foster informed decision-making for both routine tasks and long-term planning. Azure Monitor collects, analyzes, and visualizes metrics from a variety of Azure services, virtual machines, and application components. Each metric has a defined namespace, reflecting the kind of service it measures. By leveraging Azure Monitor's integrated platform, administrators can view real-time and historical data, generate alerts, and automate corrective actions if performance deviates from expected ranges. This approach helps consolidate performance indicators in a single interface, reducing complexity and noise. Azure Monitor's scope also extends beyond basic performance data, offering near real-time metrics for scenario-based tracking, such as container performance and network throughput, ensuring comprehensive visibility. Metrics in Azure come in two primary forms: platform metrics and custom metrics. Platform metrics are automatically generated by Azure services, such as CPU usage or disk I/O for virtual machines. Custom metrics can originate from application code or other integrated services, defining behavior that aligns more closely with business goals. Many metrics include dimensions, which provide context to the data. Dimensions break down a metric into categories like region or endpoint. This fine-grained approach helps analyze performance variances across different segments, ensuring that potential bottlenecks or anomalies are quickly detected and addressed for improved reliability. Azure's metric collection process relies on the built-in capabilities of each service, making metrics readily available inside the Azure portal. For certain workloads, administrators can configure custom metric creation to capture specialized performance indicators, such as queue length or API response times. Azure Monitor periodically polls or receives metric values through various telemetry channels. Collected data is stored in the Azure Monitor Metrics database, allowing for near real-time querying. Access controls and retention policies can be applied to maintain data security and compliance. This robust collection mechanism forms the backbone of accurate, data-driven insights for effective resource monitoring. Within the Azure portal, administrators can interactively visualize metrics for supported resources. By navigating to the Azure Monitor blade, it is possible to select a target resource and choose relevant metrics to plot on customizable charts. Users can filter data by dimensions, apply time series aggregations like averages or percentiles, and overlay multiple metrics in a single graph for correlation. Additionally, the portal supports pinned dashboards, enabling teams to track vital metrics at a glance. This direct analysis empowers stakeholders to detect trends, pinpoint performance changes, and develop immediate strategies to sustain or improve operational efficiency. Metrics Explorer is a dedicated tool within Azure Monitor that furnishes a flexible interface for in-depth analysis. It allows creation of multiple charts, each focusing on a distinct metric or resource. Administrators can apply splitting based on dimensions, compare different metrics side by side, and fine-tune visualizations by adjusting time ranges or aggregation intervals. Users also have the option to save these charts as part of custom dashboards. Metrics Explorer's comprehensive filtering and layering capabilities empower technical teams to discern patterns, detect anomalies, and perform root cause analysis without requiring external tools, leading to faster resolution of performance issues. Alerts in Azure Monitor use metric thresholds to trigger notifications or automated responses. Administrators can configure alert rules by specifying the metric, its condition, e.g., greater than a set value, and the measurement period. Once the threshold is breached, Azure Monitor sends notifications through various channels, including email, SMS, or integration with third-party messaging platforms. It is also possible to link alert rules with Azure Functions or Logic apps for auto-remediation. By using alerts effectively, teams can address issues before they escalate, aligning closely with service-level agreements, SLAs, and ensuring that resource performance remains within acceptable boundaries. Advanced analysis techniques involve combining multiple metrics or using interactive analytics in Azure Monitor. Query-based approaches, leveraging Kusto Query Language, KQL, allow for real-time correlation between logs and metrics. This hybrid perspective highlights potential dependencies or signals across related resources. Another method is using metric alerts with dynamic thresholds, which automatically adjust baselines based on historical data, reducing false positives in cyclical workloads. Additionally, administrators might deploy near real-time analytics for mission-critical applications, incorporating intelligent dashboards that integrate predictive modeling. By adopting advanced analysis, organizations gain proactive insights into their cloud infrastructure, enabling smoother operations and optimized resource usage. Power BI integration offers an extended view of Azure Monitor metrics by merging them with enterprise data. This approach facilitates a broader picture of system health and business outcomes, making it feasible to correlate resource performance with user engagement, financial metrics, or operational KPIs. Through data connectors, administrators can import Azure Monitor data into Power BI, build interactive reports, and share them within their organization. These reports can include visuals that show trending, forecasting, and drill-down capabilities. By coupling metrics with contextual data, stakeholders can uncover hidden relationships, helping them make smarter strategic decisions for future growth. Effective metrics monitoring in Azure demands systematic planning. Teams should identify essential metrics aligned with specific business objectives, focusing on measurements that highlight potential risks. Employing dimension filters encourages deeper insights into localized issues or usage patterns, while setting up well-designed alert rules ensures timely responses to performance deviations. Furthermore, adopting consistent naming conventions and tags across resources can streamline analysis. Regularly reviewing and refining dashboards helps maintain alignment with evolving objectives, while archiving older data for historical baseline comparisons proves beneficial in capacity planning. These best practices empower organizations to maintain stable, secure, and efficient cloud environments using Azure Monitor.